Welcome, engineers. My name is Travis IQ, and today's CCNA at lunch. We've got the rundown. My first topic on the rundown, we got CCNA study tips. That's what we're doing all week, right? So that's really not technically the first topic. The first topic is what not to do. If you remember yesterday, I talked about what I would do, what the most important thing to study is, and how I would start my CCNA studies, especially if I was starting basically from ground zero, maybe with a little bit of technical knowledge about, I don't know, Windows operating systems and kind of, networking in general. What I'm gonna do today is what not to do when starting out. Now, this isn't to say that these topics are not important. They certainly are important. But if I were beginning my CCNA studies, or even at the middle side of the beginning, if I were in the first 50% of my CCNA studies, these are things that I would not focus on. And again, I'll continue to elaborate on this as we go. But what I wanted to say was what I wouldn't focus on would be protocol specifics, nuance associated with protocol, nuance associated with dynamic routing protocols and protocol decisions. What do I mean by this? What do I mean by nuance? What I mean is, let's take something like Ethernet headers, specifically the MAC address header, right? In the MAC address header, there's a field called ether type. And you will see in questions and in quiz questions and on other CCNA study material where people talk about the ether type field and 0x0800 as the common ether type field. That's the ether type for IPv4. Okay, what does that really matter to you in terms of your understanding of networking fundamentals? It helps when you're looking at, let's say, PCAPs in Wireshark or in TCP dump or something like this. It might help you, more fundamentally understand what's going on in the packet and things like this. But from a pure getting up to speed standpoint, trying to understand the CCNA information, ether types and hex associated with ether type headers and different layer 3 information that can come after the MAC address header and how it's denoted in the hex and the ether type field doesn't matter. Don't focus on that stuff. All the words that I just said previously, if you're not familiar with a lot of these things, don't get overwhelmed. So this is an idea of how not to get overwhelmed with CCNA studies. Let me give you some other examples. Some things like IP header specifics, type length value, checksums, how the checksums are calculated. Don't worry about these things. They are important in the huge picture, but in the idea of getting up to speed, you're not going to drive a car and ask how the bearings work in the wheel. You're not going to drive a car and ask what the fundamentals of the flame profile in the internal combustion engine are, right? What you want to know first is steering wheel, 4 wheels, major components of mirrors and side mirrors and where people are in space, speeds. That's what we're looking for in terms of the CCNA as well. A few other things that I wouldn't focus on. I'm trying to tell you things that I think are at least frivolous endeavors to study at the beginning would be things like dynamic routing protocol. So the second half of the CCNA, right? Obviously, you're going to start in the front half, but I just wouldn't get overwhelmed with what some of the second half topics are too. Things like dynamic routing protocols and OSPF and some of the specifics of OSPF and EIGRP. I would also say when you're starting the dynamic routing protocol sections and you're starting to learn about these things, I would not worry about some of those specifics that you might see tested on a CCNA and that you have to learn, but you don't need to know them to start understanding how routing protocols distribute routing information and how we get information about how to get from one network to another. Do not worry about things like the diffuse update algorithm, dual, or the Dijkstra algorithm, or shortest path first mechanisms, or things like RIP and hop count metrics and what happens when your EIGRP or RIP, these distance vector routing protocols, advertise networks back to their sources, which they won't do due to things like split horizon. That doesn't matter to you when you're starting to learn about dynamic route distribution. What you want to know is, how do I get one route to another router, right? How do I get that route information there? What does it look like? How do I make the decisions, right? What are some values that allow me to make these decisions? What intuitively is going to help me understand these fundamental metrics better? Okay, so those are some things that I would not focus on, right? I would focus on, the second half of what I talked about, right? What's actually going on, right? How do packets get from one place to another? What does that header information look like? That brings me to my second point, which is this data scenario. What is this data scenario? It's actually a scenario that I bring up all the time in my courses, and I talk about why you need to know this, and if you do know how to do this, you will be much better off in the long run. And the scenario is, it's a very simple scenario. PC1 is trying to get information from a web server. And in this scenario, I've got PC1, right, communicating to the internet, the WAN. And on the other side, I've got a web server, right? And so my question to you is, and this is something that's really important and will really help you fundamentally understand networking and the CCNA, right, is how does data get from PC1 to server 1, right? How does data get from PC1 to server 1? And specifically, I'm talking about encapsulation. So how does data get encapsulated by PC1? And if I'm making a web request, so what I'm actually saying is, how does the HTTP GET request, so this is the application data, get packetized, right, encapsulated, and sent across the WAN to S1? So the one component is encapsulation. What information do I have in the header that allows me to get from PC1 to server 1? And the other one is physically, how does it traverse, right? Because we probably have a switch here, and I have routers in here. And so what does the hardware actually do with that information? So how do we encapsulate it? And then what does the hardware do with that information? And by the hardware, I mean the switches, the routers, and then the NIC on the other side of S1. If you can explain this scenario, you have a better fundamental networking understanding than a lot of people who are even in the middle of their CCNA studies, because they do not go to this fundamental discussion here and go, hey, how does data get from PC1 to server 1 when I make a web request like an HTTP GET request? Very, very important concept that we need to understand fundamentally. And I'll start off by saying I would start with the OSI model. Right? Where do we encapsulate data? What layers, and what does that information look like? And realistically, again, I said don't focus on like crazy header specifics in terms of TLVs and checksums and things like this, but source and destination information is really how I get from one place to another, by the way. So what does that source and destination information look like in the OSI model and in those headers? Layer 2, layer 3, layer 4. If you can understand the source and destination and what the hardware does with that source and destination information and what happens when it gets to server 1, then you will be light years ahead of a lot of people. That includes even some junior network engineers who can make some config changes and got hired into a situation where maybe they aren't as familiar with this stuff as they should be. Okay, we've got just 2 minutes. If you remember on my rundown, I had one other thing that I wanted to do. And if you remember, it was actually a simulation mode. And so I talked about Packet Tracer yesterday. And what I wanted to do was bring up Packet Tracer one more time and show you one of my favorite things about Packet Tracer. So we're probably going to end every day with a little Packet Tracer discussion. This is a small little Packet Tracer network here that I have made. PC1. It's actually similar to that discussion that I made with you, right? PC1. I've got a switch, I've got a router, and I've got a server down here. And so if I wanted to look at, remember, data going from one place to another, if I wanted to look at data traversing the network from PC1 to server 1 here, I could go into PC1 and ping from PC1 to PC2, to server 2. And in this scenario, my PC1 is 192.168.1.2, my server 2 is 192.168.2.2, and if I ping across this network, if I give it a second here, it will resolve this ping from PC1 to PC2, but I'm in simulation mode still, am I not? I should be in real time. And now it will resolve. Okay, but I didn't actually get to see the packets go anywhere, did I? I didn't. So what if I went to simulation mode in Packet Tracer, which I said I really like? What simulation mode in Packet Tracer does is it actually stops time, right? It stops time and allows you to move time forward frame by frame to look at that packet transfer, right? And so if I wanted to do this again, if I did this exact same thing, and now my time is stopped, nothing is occurring, but the first ICMP echo request is here. I can actually click on this and I can look at some information here as well, some packet information, or I can move it forward in time, frame by frame, basically, as it gets forwarded to the switch, as that switch forwards that traffic onto the router, and as that router forwards traffic on to the server. I encourage people to use this mode all the time to understand how the network is working. If you have an advanced network scenario, or if you pull a packet tracer lab from something that I post, and you want to know what's going on in this network and you don't understand why a packet is failing. For example, if I were to send this ping, I know we're running out of time here. We've subsequently run out of time, but I'm going to do this anyways. If I send a ping, if I go back to simulation mode and I send a ping to the wrong IP address, 192.168.2.3, and I try and do this, and I go forward in time, this router is sending an ARP request looking for the MAC address of 192.168.2.3. The router is not going to know where to send it. I have a request timed out. The router's not even going to give me a destination host unreachable. It knows the network to go to. It just can't find a MAC address to send it there. Yeah. Anyway, there's a good example of how I might use this to identify what's actually going on. It's showing me that there's a failed ARP request here as well. That's the end of our session here. We're going to continue on. We'll probably end with some packet tracer discussions every day this week. As is always the case, engineer, break stuff, and have fun. I'm out.